Very good evening, everybody. Welcome back to this session on deployment. Apologies for connecting from my car. Um, yeah, we live in a world where there are a lot of uncertainties. So one of them is today. I'm stuck in traffic. Luckily, I could find a spot to quickly start the session. And as they say, the show must go on. So on that note, um, let us start. Um, so today we are going to be moving to the third phase of our deployment journey. So we are going to be working with this Fast API web framework, all right, which is kind of similar to Flask that many of you are already aware. Now, Flask is something that is probably the primary classes. I think by now you must have realized, and we are going to work with Fast API and Docker. Those are the two things that we have planned for today, and this is also used extensively for image processing applications. All right, so real heavy applications is what is the capability of this particular application. So on that note, I'd like to now invite Sharath to please take over. Please.
Thank you, Nitin. Thank you so much, and really appreciate you joining, even when you're stuck in the traffic. Thank you so much for that. I'll take over from here. Thank you so much. Hi, everyone. Good evening, and welcome back to the channel. And as we promised, every weekend we will come up with one use case, one tool basically for deployment. And like we discussed in the last session, we will be taking up with the Docker and, of course, the Fast API. We will focus heavily on Fast API, and then we'll also talk about how Docker can allow us to do the deployment of ML models. We'll not jump into a lot of technicalities of, you can say, the Docker or the Fast API, but we will see how these things can actually help us to bring our application into practice, so that the end users can actually use this using some web frameworks, web interfaces. So REST APIs have to be created, and when we talk about this REST APIs in Python, we have the three most important web frameworks, and Flask is something that we've spoken about the last session. And this week we were going to talk about the Fast API. We also have Django, which is another full stack web framework development toolkit. We will pick it up probably in the next session. So we'll keep up that information up to date with you people. But this week is all about Fast API. So let me share my screen and talk about what exactly is Fast API. And let me start here. So there you go, friends. We are going to try and do deployment of machine learning models using the Fast API and Docker. Of course, we will also have the intermediate things like Python programming, which is the heart and soul of the entire development. That's the programming language which we will be using. We'll have GitHub repository, though I'll not be talking about GitHub repository today. The same functionality will be there, like what we have seen in the last session. Just to ensure that the time is right, time constraints are considered. I'll skip GitHub related things for this particular session. We'll focus only on Fast API and Docker. All right, so let me move on. The flow, as you can see on the screen, we basically are talking about the various social media channels that we have. Right? Just give me a second. I'll try and bring up something for you. Okay, so like you see, in the on the screen, we have various data sources, right? And these data sources relentlessly get the data to us. I mean, they help us to get the data, right? And using this data, we will be trying and doing the training of our ML models. Now, when we talk about the data sources, we also have to understand that the format of the data, right, is definitely different from different sources that we are generating here. So, like you see here, the social media, majority of the data is unstructured. Then we have IoT devices, which are generating the sensory data. The web sources, these are your social media, of course, is something that also is an internet, but we probably will have various web forums where the data gets collected, the applications, the forms that the business has, and the end users communicate the details using those web applications or different various forms that the websites contain. All these are in different formats. So we will have to ensure that we perform thorough ETL pipeline, right? The data pre-processing is also part of this. We will have to extract all this data, transform all this data, and then load it into, you can say OLTP. Or you can also have analytical processing system like your warehouses or data lakes. In our image, we are basically looking at OLTPs. So I'm bringing, excuse me, I'm bringing all the data from various sources into my database. So this is a data pipeline that we are constructing here. I'm demonstrating in a very simple format. Once the data is available in our database, we are going to try and fetch the data, perform the pre-processing using our Python programming language. We will apply auto PD techniques, auto data pre-processing techniques, and all those data pre-processing strategies will be implemented. And our raw data will be processed and will be made ready for model development. This is part of your CRISP-MLQ methodology. Post this, we will try and build the machine learning models. These could be regression or classification-based models, depending on what we are trying to achieve. And once the model is developed, the vanilla model is developed, we will try and evaluate it and try to improve it further by using various parameter optimization techniques, right? Hyperparameter tuning optimization techniques, like grid search, randomized search, Bayesian search techniques. We can also use auto ML techniques, which can basically run hundreds of experiments based on the number of parameters that we are trying to pass. Ultimately, we are going to get the best model. Right? This is your best model. After doing all the trial and run experimentations, you do the data partitioning, train, test, validation, right? And we try and use train and validation data to tune the model. Then finally, we check that on the test data, and we eventually get the best model. But this best model that we are speaking about is still in a naive mode. That is, it's just like a code. Now, end users require some kind of a web interface. Now, this is where Python allows us to create these web interfaces, the APIs, you can see, which are basically very easy to create. And when we talk about these REST APIs, the Python libraries allow us to generate these web interfaces very easily. We have lightweight web frameworks like Flask and Fast API. We also have full stack web framework in Django. These are the most three popular web interface web frameworks that we can use to construct our APIs, web APIs, which we will do. I'm using Fast API here. Once these entire code along with the web interfaces are ready, then we move this code into the code repository. This is where your entire code lies. So if you have multiple teams working on the same code or multiple people contributing onto the same code, then you need to have a centralized location where everybody can try and put their efforts into. So that is GitHub repository. We have seen this GitHub repository implementation or usage in detail in the last session. You can go through to get the quick intro into the GitHub repository. You just go to the previous video of this series. Now, once the repository is ready, once the final code is ready, we can use the Docker to try and create a container or a runtime image using containerization concept of on top of your ML model, right? On Docker, we can create an image. The advantage is that we will be using this Docker image in directly taking that application and placing it in different servers. Like it could be on your local premise. You can deploy it on local premise. You can take that same image and place that in any of the clouds, like your GCPs, AWS, or your IBM, IBM Cloud, or Oracle Cloud, or Azure Cloud, right? It could be any cloud, absolutely. So hardware independent, basically, right? So that is the advantage of having the Docker images. Now, once these are ready, you will be able to use the deployed application using the web interface that we have created, right? The Fast API that we've used here to create a web interface. We will be able to access the functionality of the ML model using that web app. So we are basically talking about web API. But you can also create the end user interface by constructing or getting a mobile application developed, or you can talk about having a very simple interface where the end user can directly communicate with the model and all these things. So this is a very high level run through for the entire the flow that we are looking at here. Okay, now let us talk more about the Fast API. So what exactly is this Fast API? If you see, Fast API is the web framework. This is the language that you will see in the official website of Fast API as well. It's a web framework which has very high performance capability, and it is very recently developed. In 2018, this Fast API was created or developed by Sebastian, and it basically, the documentation says that Sebastian did not like the existing web framework, that is Flask and Django, and hence he started to create something on his own. And that's how Fast API came into existence. The advantage, right? There are a bunch of advantages, like we will be talking about those advantages in the next slide. Is one of the advantages that it is having async feature. Now, what is this async feature? Async is basically speaking about asynchronous or waiting. So the feature allows your application to run multiple programs, right? It allows us to have multiple programs run without waiting for one of the application to complete. That means it's not sequential, you can see. In short, what we are saying is it's not sequential, whereas Flask is sequential. Okay, so that is the advantage that you will get with Fast API. Parallel operations can. Then this is also used for deploying. That is what we are going to look at, the machine learning models. It becomes very easy. It's just like Flask. I mean, I really don't see much difference. There are certain benefits in Fast API, but at the same time, there are certain disadvantages with Fast API. I'll try and show you the pros and cons as well. We have one specific feature called as Pydantic. This is something that your Fast API is relying on. It uses Pydantic. Pydantic is basically a feature you can speak about, which allows the programmers to write the user-friendly. I mean, the development of the code becomes very easy when you have this Pydantic. Jupyter notebooks, right? They follow this, or Spider also. Python basically uses this. It allows hints. When you're typing Python code, you will see a lot of hints, right? So that is because of your Pydantic features. So it allows you to have more interactivity when you're trying to write your programs. It enforces the hints at runtime, and it also allows you to identify the errors very quickly. And it is also allowing us to verify the data. Data validity is also something it does. Right? So these are some of the benefits that you will see with respect to the Fast API. So in short, Fast API is nothing but an application which allows us to create web interfaces or web APIs on your Python code. Now, coming to the features, if I have to talk about the Fast API features, as we've already discussed, this is very fast. Right? It's considered to be super fast. Compared to Flask, it is much faster. Right? That's what the benchmarking tests have actually proved. So among the three, if you speak about Django, then you have Flask and then Fast API. Fast API is considered to be the quickest one, high performance. It is robust, right? It basically allows you to have a very less bug-free code, which can be directly be developed for your production environment, right? Because of Pydantic feature, as we just discussed, it well as it allows you to do a lot of interactive code development, and it in fact does automatic interactive documentation, like we will see now. I'll show you the example also. So once you run your application web framework, you'll also be able to see the documentation. It looks into data validity. That is one of the very important features. Right? It is also called as intuitive. Basically, it was designed to help the developers come up with their programming or come up with their application with ease, which Sebastian, who was the developer of Fast API, didn't find in Django or your Flask applications, you can see. So it was designed to be easy. That's the primary the objective of having Fast API. And it also allows you to do a lot of interactive programming like we have sent here. And the documentation, right, is really, really helpful in doing that. So at each line, you will be able to try and validate what is correct, what is not correct, and you can try and correct your code errors, bugs that you're going to get. Then it is very, very compatible. It follows a lot of standards, right? Like you see, open source standards that we look at. Open API is predominantly used. So it works very well with a lot of these standards, global standards that we have. Open API, as I said, is something which is predominantly used by your Fast API. Of course, JSON schema, right? So these are some of the standards which Fast API supports. Again, the features are ultimately ensuring that the programmer can develop the code very easily. So you can see quick to code, fewer bugs. There are readily available a lot of plugins, the type hints that you see because of the Pydantic features. And ultimately the features are helping us to develop our program with much precision and with more accuracy. And you can also say with better performance. So that is the objective. These are some of the features that your Fast API has. And if you have to summarize everything, right, the comparison is something that we would like to talk about. I will come back to this example. What exactly is the code doing and all that? This is the code snippet. I will try and explain each and every line here. And but before that, let me talk about the comparison between Fast API and Flask. So if I talk about Fast API, one of the most important feature that it has is the data validation. It basically allows you to focus on your program, right? Your code. It takes care of validating your data automatically. It does that, right? And the disadvantage in Flask is that you don't have that. You can see no data validation in Python Flask, right? So whatever the data you can pass, it blindly accepts it, doesn't validate. Whereas Fast API does the validation. So you cannot just pass any random data. That's the first benefit that you see, data validation. Exception handling, right? With Fast API, a lot of interactive documentation is available. So it's very easy to deal with your errors, the bugs that you're getting, right? So exception handling can be very effectively be performed in Fast API. And this is another right, very important feature, asynchronous code support. This allows your Fast API to have multiple operations being parallel. You don't have to run the application sequentially, right? That's the advantage. Supports async code using this features of Python, async or event. These are Python features, of course. The request validation that you talk about, right? Because it uses this pedantic feature. It is not very comfortable in some of the instances, right? It is not always intuitive. And in order to ensure that the bugs are reduced or the customizations are actually obtained, because of this validation point, though it is treated as an advantage, but in certain cases, the errors might creep in. So you will have to do a lot of custom program in such scenarios. You'll have to write your own validations. This is one drawback that you will see. In certain cases, it becomes a drawback, depending on your needs. You'll have to do the customization. The Fast API is developed in 2018 and it is slowly catching up. It is not as popular as the libraries of Python, which is Flask and Django. It is slowly picking up, but yes, very aggressively being also picked up. From that perspective, the support is not that effective as per that we have for Flask application or for Django application. For these applications, they are very old compared to Fast API and they're more matured. So support, the contributors are also more, the community is big. So you'll have good support there. Here we will have small support. Now coming to the Flask, it is flexible, right? You can manipulate your Flask applications. That's what it means. Of course, in Fast API also, you'll be able to do that. Intuitive, yeah, this is another feature which is common. Fast API also has the intuitiveness. And this considered to be very good, easy for beginners because of its simplicity. Here, yes, it is also simple, like you'll be looking at Fast API code. But once you see Flask application and once you get used to it, the certain things in Fast API probably might confuse you. But if you're beginning with Fast API and then probably go down to Flask, then you will see that you will be more comfortable in Fast API. Syntaxes wise, not many differences. Both are very similar, right? But it all depends on the intuition and usability. Once you get used to it, you probably tend to feel comfortable in one of these two programs. The built-in development server. This is another advantage that Flask has. So it is also known as your microwave framework right, service. So this is a built-in functionality, right? And because of this development server, you don't need to have any other additional server supports and all that. You basically get a development server within the Flask API itself, and this allows you to do the testing and all those things very easily. The disadvantage, though, as I already spoke about this point, data validation doesn't happen here. And it is a little time consuming compared to Fast API. The name itself is fast, right? So remember that. this is a single source, right? And the execution happens sequentially, right? Requests in turns, meaning that basically you will have one task to be completed at one time. So it takes a little more time, and it doesn't have this async feature to parallelly run the programs. So this is the comparison with respect to Flask and Fast API. Now, if I come back and try and explain the code, okay, this is a very simple code snippet. In the official document also, you can see this code. This is the famous Hello World code. All we are doing is installing the library. So you will be saying Fast API, right? I mean, like any other library, we will say pip install Fast API. Very simple. You can also say all, so that all the dependencies can also be installed here, right? So that is the pip command. Once it is installed, you will be able to import it using the Fast API import Fast API library. Then we will have the lines of code here. This is a custom function. This is the routing that we are doing, and this is your main application. So let me try and explain what exactly we are doing here. Okay, so to start with, I'm going to say the file name, right? So I'm labeling this file as hello.py. It's a simple Python code. So I will have .py extension, like Flask again. Even for Flask, we have Flask. Your app.py or some file name.py, right? So it's a Python script. So here also it's a Python script that we look at. And the first line of code, let me explain that. The first line of code that we talk about is to import the library, right? Import Flask API. Once this is imported, the second step, this is the code. This is instantiating your model, or you can say API. So we are creating an instance for this class. We are labeling this class as APP. This is my application. I'm giving it a name. I'm not passing any arguments or anything for this API, the application. Default arguments, no arguments in fact. And this is the application that name, right? This is the app name that we will be referring when we start the application. This will route to the operation. This is called as operations. We are doing get operation. What does a get operation means? You can see this is allowing us to read a data. So these are different types of operations that we can perform. And this is one of the HTTP methods, the basic ones. There are other operations also, but we are speaking about these 4 for now. So we speak about post. This is to create data. Get is to read the data, right? This is like read underscore CSV if you want to imagine. Then put is basically to update if you have any data. And of course, delete is very straightforward, deleting the data. So these are your basic operations. Here we are doing get operation. Then comes the function that we need to run here. So what happens is the routing is being done here. We are routing the application, the REST API, to the home directory, the root directory. So you will have the URL, and then you will have routing, the slash. This is like your endpoint. Okay, so it is basically triggering or routing us to the root function. So this is where we are defining the custom function that we want to execute. Whenever we reach this path, it triggers this custom function. What we are doing here, it's a very simple Python custom function. we are returning a dictionary, which basically says hello world. This is the key and this is the value. So this is a dictionary that we are trying to return when the path is accessed. Right? Very simple commands. We basically, again, if I have to summarize the steps here, you can see we are importing the library, creating an application instance. We are declaring the path using something called as decorator or operator, you can say. Here we are using get operator and the path is root. Then we are defining the function, right? Get function. Here we are basically doing the dictionary return. Once the code is ready, in order to trigger this application, in order to start the server, you use UVCon as the keyword. I mean, this is where your application runs, UVCon. And on UVCon, you're basically calling the file name and then your application. And then you have reload. This is to ensure that the changes are read. This parameter will basically ensure that the server is automatically restarted if there are any changes in your code. You can, this is optional, you can ignore this. You can manually reload if there is any change. You don't have this. So this is basically how we run. The app is nothing but the application that we have defined here. And the file name, that is your hello. So this is the command that we are running, and this will start your Fast API server. And this will return the hello world. So this is how your code can be explained. And as we discussed, there are other applications of that operations that will also allow us to deal with. Now, one thing we need to remember is the specific feature of your Fast API is your data validation. Right? So it automatically does that. Data validation is something that it will automatically do. Next. This is with respect to your web framework. Okay. Now, you will have your code, right? Your entire ML code, and then you will have your web framework, REST API commands. This is going to be like a wrapper around your code, right? And you know how we have done the coding in Flask also. You'll have the entire web interface, the API code, this is being defined, and then within it, in the custom function, you can use your ML models. The same models can be used for prediction purpose. Same logic will be applied here also. Now, once this application is ready, let us assume the ML code is ready, the Fast API web framework or REST API is ready. Then, in the last session of the series, we have used Heroku Cloud. It's a platform as a service that is available, and you're going to push your code into Heroku. And there you will get the edge point and all those things, the URLs and all those things are available. But what if I want to deploy my application in a different platform? Not in Heroku. Heroku is like a readily available platform. But from a client perspective, let's say as a client, I want to do this deployment in a different server altogether. I might have development server, I might have production server, I might have test server. These servers could be on local, these could be on cloud. We don't know what could be the client requirements, right? So we need also that flexibility which allows us to take our final code and deploy it in different servers. The biggest problem with this is this one. I mean, just to add some humor, no disrespect, but if you remember this display of the vehicle, the Elon Musk, the car, the future car that we talked about, on the stage, when the challenge was thrown, right? On the stage, the glass cracked. They said that the glass would never be broken. It's unbreakable. That was the claim. but on the stage, on the launch, it did not work. Right? So this is a classical problem that we will have. Your ML, right, engineers, they will develop your ML app. They test it, they do it, and right, they probably validate it, they measure the metrics. Everything is done on their system, whatever the server that they are using. Let's say server 1, or I'll say development server. So it works on this particular development server because as part of the development, we will require all those dependencies, right? And those dependencies are ensured that are available here. Now, these dependencies could be hardware related dependencies, software related dependencies, or OS level dependencies, or app cross functionality related dependencies, right? Could be anything. We don't know. So from a development perspective, we will ensure that these things are anyways addressed while the development process is happening. Now, if I take the final application and do this on test environment, or for that matter, if I have a production environment, then, so I'll talk about test server. This is a different hardware altogether, right? So we'll talk about production server. The problem is there could be different hardware or software standards being maintained in test server and production server. It's not mandatory that your development server, test server, and production server should be identical. Different organizations have different standards. They do not shell too much of money on development or testing servers. But production servers, definitely they will be very high configured and they're powerful basically. So in such cases, because literally physically these computers, these servers are different, the application that you developed in one system may not work in another system. This is the biggest challenge with respect to your any application development. Now, ML is no different in this area. You'll also feel the same problem. So this is where we will have the Docker coming into the picture. So what is a Docker? And what is Docker to start with? So you can see Docker is basically a very simple software, and it allows us to create, deploy, and run applications on any server. All we need to have is that software installed, irrespective of the hardware and software requirements or standards that these servers are maintaining. This is done using something called as containers. Now, last session we have briefly touched based on what does containers means. But yeah, next slide I will talk about that. Now, Docker is a software which is OS independent, right? And platform independent, you can say. It can run on local, it can run on cloud, it is Windows, Mac, Linux, right? So it works on any computer. All you need to have is a Docker software. And we will have this Docker engine. And this Docker engine is responsible to generate our runtime environments. So it initiates your application containers. These application containers are running as if they are supporting the services on any server. Okay, so Docker engine is responsible for giving us the runtime. And it's basically a software, or you can say a platform, which is available as a service for various products. And what does it do? It does OS level virtualization. When I say virtualization, again, we literally go for virtual machines and all that, but containers is completely a different concept. So OS level virtualization is done, not at the hardware level virtualization. And these OS level virtualizations are called as containers. And these containers are completely disjoint, isolated, independent. And each container will have its own requirements and everything. Basically, all the related artifacts are available within the container. It kickstarts the containers based on the requirements document that we have. All the dependencies that we require are also documented in it. So taking all those OS, even OS related dependencies to run your application. This way, irrespective of where you are running, your application will run. the server could be anything. So that is the advantage of having your containers. This is basically the demonstration. You can see the image which speaks about your containerization or containers. So as we discussed, a container is nothing but a software. Again, it's like a software, which is, you can say at BIOS level, you can imagine, is a standard unit of software which allows us to package the application and related dependencies. Right? Now, if you package everything together, then application runs in any operating system, in any computer, because it has all those things which are required. Right? It does not depend on the operating system or any other softwares that are running on that server. This itself is like a standalone application which can run. It just needs a hardware. That's all. So as we seen in the last slide also, it is nothing but OS level virtualization. Okay. And it does not require VMs. So if you look at this image, this is your containers technology. This is the logic. This is where your hardware is, right? Your system resources, you can see, hardware resources, you can see. On top of the hardware, you will have operating system. In the operating system, you'll have different softwares. You'll also have Docker. So the Docker engine is, right? Of course, this was initially started with Linux operating system, but later on it was developed for all the applications, Windows operating systems also. Microsoft has spent a lot of time to give this kind of a feature, Docker engine feature, right? Containerization feature for Windows applications as well. Now, Windows operating system, I should say. So the Docker engine, which is sitting on top of OS, it could be, as I mentioned, Mac, it could be Windows, it could be Linux, right? Different flavors. Irrespective of that, what it is doing is when you are trying to create a container, it takes all the dependencies that are required, the application, and along with this application code, it also, right, packages the library files that are required or the binary files that are required to gather all those dependencies which require for this application to successfully run. Now, I can create multiple containers like this. These are independent. This is a separate application. This is a different application. All of them are running on the same server. All of them are consuming the same hardware resources. Right. So this is the containerization image. And the application that we're speaking about, the containers, they contain all the runtime components which are required. Everything, the files, the softwares, everything are packaged together. Okay. And yeah, the advantage, as we discussed, it doesn't split your hardware virtually. Hardware is same. At the OS level, you are splitting the containers separately. This is basically how your Docker image or snapshot can be built. And using Docker engine, we containerize that particular image. So the Docker image is basically nothing but the package. Everything that we speak about, right? That is nothing but your image. And this contains everything that is required for your application to successfully run. When I say everything, all the dependencies, the OS related library files or binary files, the application related dependencies, there could be version mismatch issues, right? So what version of the application you are using, all those things are packaged together along with your code. And then we simply put this image, we build this image, right? And then we register this image into the repository, standard repository. We call this as Docker Hub. And from there, whenever we want to use that particular image, we can containerize that, right? So we can say, right, start container run. This is going to allow us to have the application as a standalone container. And this container can be used for accessing the application or accessing the functionality of the application. And yeah, it doesn't have any shells, interactive shells, right? It has to be through Docker image itself. And these images do not consume a lot of space. That is another advantage. And community is very, very huge. And you can see the Docker hub. You can just Google for it. There are millions and huge number of Docker images that you can readily access. If you are already familiar with Python programming, then I would say Python packages, pypi.org. I'm just trying to draw some synergies, friends, here so that you people understand. pypi.org is the centralized repository for Python. For Docker, you have Docker Hub. Here you'll have a lot of packages. Here we have images. This is also public community based. This is also open source public community based. Right. So this is how we will have, and we will, whatever the application that we are developing, we are going to convert that into an image, and we can place that into the default Docker Hub. You can also have customized Docker Hubs, and every cloud platform has their own repository for these images. So this is basically how your Docker image can be run. You'll have a Docker client, command line interface. There we basically try and create the image, and then we try and start the containers, right? We kickstart the containers. So we build, we ship it to the repository, and then from there we run it. So that's how your Docker containers can be started off. Now let us look into the hands-on. Okay, so I would request my colleague Aditya to share the screen. Unfortunately, I'm not able to showcase the entire deployment in my computer. So I requested my colleague to share and walk us through with the implementation. So yeah, Aditya, please can you share the screen and share the code, please? I will be talking about the the entire application. I'll quickly walk you through with this code. So you can see there are these libraries from Fast API, import Fast API, then from PyDantic, we are importing the base model. The Pickle software, the Pickle library is for saving our model and loading our ML model. Then we have the usual NumPys and Pandas libraries. And UVCon is also something that we need for instantiating and running your Fast API application. There is one question. Let me take up the question. What is the difference between containers and image? Okay, so image can be seen as the software code. So in the Docker, we are basically having the application, right? The code. Along with the code, we will have requirements document. We will have standard Docker file, which basically documents the requirements. Post that, when you want to use that image, you need a service, right? I mean, it has to start. It has to be servicing your requests. Image is like just a code, and container is like your executed service. Functionality can be accessed through containers. The code will be the image. Okay, so it's like image is the code, and containers are like your executable application, which is designed from this code. Hope that answers your question, Sahil. Moving on, this is the application instantiating. Line number 8, we say app is equals to Fast API. This is how our application is named. And here we are defining the base model. The application that I'm talking about is the fuel efficiency prediction example, which we have seen in the last session also. We will be looking into the bunch of input fields. We're reading the input fields. And here we see the MPG prediction. This is the custom function which will be called in when we say post, right? So the post function, as we've seen, right? This is one of the operation which will allow us to create the data and access it, right? So get is to read the data, but here we are trying to create the data. I mean, post, when you say predict, it generates that data, right? So that is the logic here. And the custom function that we are triggering is calling the base model, which reads the inputs. Now, once the data is in read, we use the saved model, the model underscore pkl, pickle model. I'm loading that pickle model and using that model for doing the prediction, right? So accessing the data, then converting that into a data frame, then using the predict function to do the predictions. And these predictions are written on the screen. The default URL is the local host when you initialize your application. And this is, as we said, is using your UVCon service and right, prints the outcome. Now, can we go to the Docker file, Aditya, please? Yeah, so this is your Docker code, friends, Docker image file. It starts with the Python version. The current version that we are using is 3.9 in the system. Then you will have the buffering statement environment. Basically, it is for stopping the Python buffers. This is by default, it's there. Then we have the OS level dependencies. It ensures that your Ubuntu server, we are using Ubuntu here. Operating system libraries are Ubuntu. So Ubuntu packages are updated. Right? And then we are trying to ensure that the pip software is always up to date. So within the image, we'll always ensure that we'll have the latest of the pip software, because it has to internally right, bring in all those Python dependencies that are required. Then we have the current working directory. We've defined what is the current working directory. We give a name. Within that working directory, we will have requirements. We are copying that file there. And then we have the install command, which looks into the requirements file and then installs all those dependencies that are there. And then we are copying the entire thing into the main folder, the current working directory. Right? And we run the model here. Line number 29 basically says run the Python application. And right, this is basically going to give you a container which is exposed to the external environment via the port number 880. We are exposing the application to the external world using the port number 8000 by default. Here it is 880. All right. So this is basically the code in Docker file. We don't have, right? You can see we don't have any big coding requirements here. All the dependencies are done, and then finally at the random line number 29, we are executing our actual Python code. The model.py is your ML model that we have. So it executes that. And within the model py, we are also, right, within this, we are also trying to bring in the fast API. So this is about your Docker file. Now let us try and instantly initialize this Docker image and create a container. Can we go to that command prompt and run the lines? So we'll use Docker. We'll have to install the Docker software. Yeah, we can go to the current working directory. The folder where our right, software is there, we will have to redirect to that folder. That's basically your current working directory. Yes, this is our location. And you can see we have pickle file, we have the Docker file, we have our model.py where our fast API application is also. And yes, Docker. Then we are trying to build Docker build -t. And then you have the name. Yeah, this is the name that you want to give for your image. And 1.0 is the version. And then we execute it using the dot. That's the current working directory, right? So we use that dot to kickstart. This is going to create a Docker image. Let us execute that. So it is building the image. You can see it's right, taking steps one after the other and installing everything, and then it is throwing the error. Requirements.txt is missing. Yeah, let's just check that. Yeah, can we just copy that requirements.txt file into the folder and rerun the image, please? Okay, done. So yeah, so once the requirements document is updated, it is now executing fine, right? So you can see the Docker image has been built. Now let us initialize the container. Can we start the container now? Yeah. So you can see these are the images. So you say Docker image, the ML-deployment, the tag is 1.0. That is the image that we have created, and we have image ID also. Using the image ID, we will now start the container. Yeah, Docker container run and the image ID. This is going to initialize our container. And you can see the right URL there. So the application is up and running. Can we also see the Docker containers running? You can probably take another terminal and just run the Docker commands to see the images that are running, the containers that are active and running. And yeah, you can also show the UI. Yeah, Docker container ls-a, listing everything. A means all. And yeah, this is the container that we just have initialized 47 seconds ago. Now, can we show the UI also for this particular application? With respect to the time, right? So we don't have much time, so we can just show the Fast API application. Yeah, so this is basically what we are looking at, friends. You can see the predict is the tag, and you can see the parameters. The schema is something that it is validating, request body, and these are the right example values, right? Yeah, so this is basically the inputs that we are passing. So using the Fast API UI only, we are trying to do the post, and then we'll execute it. And right, this is going to give us the final result. It's redirecting to that /predict. And once we go to that path, the code is getting executed and we are seeing the result. Right. So this is how we can deploy. Of course, the UI can be enhanced. We can also use our own templates rather than using the Fast API standard templates. We can embed our own templates and then showcase the UI much beautifully, whatever applications that you want to add with respect to user experience or user interface, we can do that. This is a very simple sample code that we are running through so that you can understand how Fast API and Docker can be used for deploying the applications on any system. Now, what we are doing is we are initializing the Docker container on our local machine. You can have the Docker software installed on your cloud, any cloud platform, and then connect to the Docker Hub, which is your standard repository. You have already initialized the image. You have registered your image there. You just built the image here, but you have to register it. Once it is registered, it will be there in the Docker Hub. And irrespective of where you are accessing it, you will be able to get the image. And then from that image, you'll be able to deploy your application. So this gives you the flexibility, right? It basically allows you to work with your ML deployment without having any dependencies on your hardware. So this is the benefit. And with respect to the deployment, we have successfully seen how Fast API can be used in place of Flask. and Docker can be used for ensuring that the server dependency is removed. So this is basically your the entire application. And if you have any questions, you can always connect back with us. You know the channel, you know the website 360 Digit MG. You can share, comment, and subscribe to the channel to get more. We will conclude the session today with this cheat sheet and the Docker management. And next week, we will again connect with another interesting tool that can be used for deploying your ML applications. So hope you have learned something new. If you liked it, please once again request you to subscribe, like, and comment the video. Until we connect again next week, have a very good health and enjoy your day, friends. Thank you so much. Keep learning and stay safe. Thank you.